All right, one more system of inequalities just so that we can review as many graphs as we possibly can. And so here I've got x squared plus y squared is less than 9, and then y is greater than x cubed plus 2. So what I'm going to do first is step 1, which is graph the equations that I have. So my first equation is x squared plus y squared equals 9. Hopefully you recognize that as your good friend the circle that we just began talking about. So for this circle, there's no left or right movement on either the x coordinate or the y coordinate. So the center is 0, 0, and then the radius is 3. When we go to graph it in just a moment, notice that I've got an equals there. And then step 1 for this, I'm going to graph y equals x cubed plus 2. So notice this is our basic cubic function, and then it has been raised up 2 units. Okay, so I'm going to go graph these one at a time. So let's see what we got. I'm going to come over to the graphing board. So the first was I have my circle. My circle has a center of 0, 0, and then a radius of 3. So I go 3 units in each of my 4 basic directions. And then I'm going to do my best job to connect those dots. And since there was equality, I am going to go ahead and I'm going to use a solid line. So now I need to know, where am I going to shade? Am I going to shade inside the circle, or am I going to shade outside the circle? So I'm going to go back to my board and I'm going to pick a test point. So come over here and I'm going to grab a test point. So we are going to test, since 0, 0 is the center, but remember 0, 0 is not a point on the circle, so I can pick 0, 0 in order to test. So we're going to test the point 0, 0. So when I do that, I've got 0 squared is 0 plus 0 squared is 0, less than or equal to 9. That is a true statement. 0 is less than or equal to 9, so I'm going to go back to the graphing board. Sorry to make you dizzy. And since I plugged in 0, 0, I got myself a true statement. What that means is for the circle, I'm going to shade inside the circle. So there we go. There's our first graph done. Now the second graph was y equals x cubed plus 2. So I'm going to take the x cubed graph and I'm going to move it up 2. So that means that my vertex, or my central point here, is going to go up 2, and then I go over 1, up 1, back 1, down 1, then over 2 and up 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then back 2 and down 8. So 1, 2, 3, 4, 5, 6, 7, 8. Again, there was an equals associated with this graph, so I'm going to connect these with a solid line. Okay, so far so good. So again, I have to test where I'm going to shade with respect to the red graph. So again, 0, 0 is not on the red graph, so I'm going to test that. Remember, you can test any point you want as long as it is not on the boundary. So here I'm going to test the point 0, 0. So when I test the point 0, 0, what it looks like is I've got the y value 0 greater than 0 plus 2. 0 is not greater than 2. This is a false statement. So what that means is where the test point was not a solution. I'm going to shade in the other direction. So we're just about done with this problem. Back to my graph. So here is my cubic graph. We tested the point 0, 0. So that means that I am going to shade on the other side of that. And once again, the solution to my system of inequalities, the region that represents the answers, is going to be where those shadings overlap. So those shadings overlap inside this area right here. It includes the ends, or excuse me, it includes the boundaries, because we have equality, so I can shade over the whole thing. So like that. Oh, that's beautiful shading. And that is another system of inequalities graph.